we have Chebyshev's theorem. It's pronounced, at least Americans pronounce it Chebyshev. My Russian son-in-law would probably have a good time with that pronunciation, and I'll have to ask him sometime. But that's the way I'm going to pronounce it, because that's the way you'll probably hear other people pronounce it. This theorem says that the proportion 1 minus 1 over k squared of a distribution must lie within k standard deviations of the mean. Now that's pretty abstract. What in the world does that mean? Well, let's go to the blood pressure example. Okay, in the blood pressure example, we had a mean of about 140 and a standard deviation of about 10. The standard deviation actually is around 8 or 9, something like that, pretty close to 9, but let's just round it off to 10. Chebyshev won't really mind that much. Now, being sloppy like this, we really could, maybe in some distributions, come up with a distribution where we violate Chebyshev's theorem by virtue of the fact that we're being a little bit sloppy here. That doesn't really violate the theorem, that just appears to violate the theorem. If we use the precise numbers, we cannot violate the theorem, and we're not going to violate it with the blood pressure example. Now, what would this mean? Let's say that k equals 1. That says then, well, actually k equals 1 is not a very interesting case, is it? Because 1 minus 1 over k squared would be 0. And 0% of the distribution certainly does lie within any distance. So let's say k equals 2. Okay, this says that, well, first of all, 1 minus 1 over k squared is 1 minus 1/4, which is 3/4. So this says that this proportion, 3/4, of the distribution is within, and has to be within, 2 standard deviations of the mean. Can't be less than 3/4. Okay, 3/4 of the distribution does have to lie within this distance of the mean. Now, if we go back to that data, and give me a second to dig it out. Okay, here's our original data. We have these values. Now, which of these values are within 2 standard deviations of the mean? Well, within 2 standard deviations of the mean, that means, just interpret this, the mean is 140 and the standard deviation is 10. Pause for a minute. Think about what you would estimate the, or what would be the numbers that would define 2 standard deviations from the mean. To be within 2 standard deviations of the mean, what numbers do you have to be between? Okay, mean is 140, standard deviation is 10. Give it a pause and think about it. Well, now 2 standard deviations below the mean, standard deviation is 10, that's 20 below 140 or 120. 2 standard deviations above the mean, well, that would be 20 above 140, that would be 160. If we lie within 2 standard deviations, within 2 standard deviations would be what? That would be between 120 and 160. So, within 2 standard deviations, means that we're between, no, we don't need the word, oh man, it's getting late, between 120 and 160. And this says, again, 3/4 of the distribution have to lie between 120 and 160. Well, for this distribution, that's not going to be any problem because, as we can see, all the numbers lie between 120 and 160, except for this one outlier, 167. So, the final result here is that of 20 occurrences, 19 actually lie, 19 do lie within 2 standard deviations. Okay? 3/4 of 20 is only 15. So certainly 15 lie within your 2 standard deviations of the mean. And we can use any other number. If we used 1.5, 1.5 standard deviations would be 15. We'd look at the numbers between 125 and 155, and we could calculate the fraction by substituting k equals 1.5. Check your text, look at the examples, and refer back to this one if you need to see what that theorem means.